everyone, for joining another week of In Rhythm's Lightning Talks. For those of you who do not know me, I am Jen Crawford, and I have the pleasure of co-hosting this space with our practice area consultants here at In Rhythm. Lightning Talks, they happen every week, Thursday at 5:15 p.m. Eastern. It is a place where our consultants teach back to the In Rhythm community at large, as well as to our community over on LinkedIn. And then we do archive everything onto our YouTube channel. This week, I have the pleasure of co-hosting this space with Austin Michael. He will be discussing SwiftUI Kit versus UIKit. Hot topic here at In Rhythm right now, so definitely excited to learn more. And with that being said, I'm going to hand it over to you, Austin Michael.
Great. So hi, everyone. My name is Austin Michael Komatz. Yes, my whole first name is Austin Michael. Get that out right now. I'm pretty new here. I only started a couple weeks ago, but I am the iOS practice area lead, and I'm super excited to be sharing today with you a walkthrough of SwiftUI versus UIKit. SwiftUI is pretty new. It was only released in 2019, but the changes that came with SwiftUI are just really taking the iOS industry by storm. So it's awesome to be a part of, and I'm glad I get to share this with you guys. So let's jump in. So just a couple things I want to share, like some key ideas quick, just to keep in the back of our mind as we go through this presentation. We're going to be focusing a lot on readability, on prototyping and development speed, boilerplate code, data binding. These are just some key ideas we'll keep in our mind. And let's kind of jump into UIKit and SwiftUI now. So, I mean, what is UIKit? Those of you who aren't in the iOS area or practice may not know. But UIKit it's a UI framework for developing iOS apps. It also works on watchOS and iPadOS. And it's a UI framework developed by Apple. It's been the kind of the de facto standard kit since the early days of the iPhone. It's imperative in nature. And what this means we'll go into in just a bit, because this is a big focus on SwiftUI versus UIKit, is imperative versus declarative and functional. So we'll jump into that in a minute. Like I said, it's a standard kit for making iOS interfaces. And some key notes are that it is kind of bulky and requires a lot of boilerplate. It does not support Mac. So AppKit is required if you want to make any Mac apps, or unless you're using something cross-platform for Windows and Mac, such as Electron. Also something just to keep in the back of our minds is that UIKit does provide a feature called storyboards, and it's a UI building tool. It's a GUI UI building tool. So the only thing is a lot of engineers tend to stay away from storyboards because of things like navigation complexity, right? With storyboards, you can have a lot of views in one storyboard and it can get really messy really quickly. Sometimes there can be issues with reusability, storyboard lag when you have a ton of views in one place, clutter, loss of control, merge conflicts. For example, just opening up a storyboard can change the underlying storyboard XML, which can lead to some pretty nasty merge conflicts and more. So we will not be focusing on storyboards at all. We'll be doing all of our UIKit demos in code. So that begs the question now, what is SwiftUI, right? So it's also a UI framework, but it's much more modernized than UIKit. It's also developed by Apple. Like I said, it was released in 2019, so it is pretty new. It's declarative. We'll jump into that in a minute. It's very lightweight, fast, and cross-platform across all of Apple's platforms, including iOS, iPadOS, watchOS, macOS, and tvOS. So you can use SwiftUI anywhere. You learn it once, you can use it for all your Apple applications, which is just, it's great. So I mentioned this already, kind of imperative versus declarative. What's the difference? So let's talk about this and go through a couple examples. because this is very fundamental to what SwiftUI is trying to accomplish, right? So imperative programming, it really focuses on the how. How are we going to do something? What are the steps we're going to take to get to a desired result? It's very old school, and it requires a lot more boilerplate to accomplish something. Again, yeah, the steps to achieve a result are required. And this is just kind of an example. So here's a question. What would you like to eat? You know, you can answer that in a couple ways, but the imperative way to answer that may be take 2 pieces of bread, spread one side with peanut butter, the other side with jelly, and put them together. That's our imperative answer. And that's kind of the feel of imperative programming. So obviously that's not very efficient. You don't want to go to a restaurant and tell someone how to make your food. You just want to tell them what to make, right? So UIKit is imperative in nature. It provides the foundation, and then you're left to construct everything and make it work together. Now, declarative or functional programming is very different. So the declarative kind of wraps around the how and focuses instead on the what. Okay, so you're not focused on the steps to get a desired result. You just care that you get that result. The how, right? The how is abstracted away from the top level. You don't need to worry about it. It's abstracted away. So let's answer that same question we answered for imperative programming. What would you like to eat? And it's a lot more simple. I just want a peanut butter and jelly sandwich. The steps to get to that result are implied. It's kind of wrapped beneath the surface here of what we're saying. I just want a peanut butter and jelly sandwich. Obviously, whoever's going to make that sandwich knows how to make it already. So the declarative wraps around the imperative. Yeah, it doesn't matter how the sandwich is made, it just matters that it is made. So let's look at another kind of real world example. Let's say in this scenario, you want to drive to your friend's house using a GPS, okay? The imperative approach might be to program each step into the GPS. So each step has to be manually entered. You decide the path to the desired location. So if you have to turn right, you have to know that, you have to tell the GPS. And it sounds kind of silly, but that's kind of what we're dealing with here. It's not very efficient. So instead, what we want is the declarative or functional approach. It's much more functional. You just tell the GPS where you want to go. It does all the path finding and it gets you there. You decide the location, the GPS decides the path, okay? So again, imperative, we're gonna say how we're gonna get there. Declarative, we're just gonna say, get me there. This is what I need, okay? And another example, you don't tell a blender how to blend. You don't tell a refrigerator how to keep things cold. They just do. They are functionally capable of doing that by themselves. So let's look at a quick programming example before we jump into the demos. So this is just an imperative Swift example. So we have over here, basically what we're doing here is we have some predefined users and addresses. We want to filter the users to find these specific users with these specific IDs and also assign them their addresses. So the imperative way might be to loop through all the users, then loop through all the IDs. If we find an ID match, we add that to the list of filtered users. And then we loop through all of the addresses. If we find one that matches the user ID, we assign that address to the user. At the end, maybe we want to sort the users by their first name and then return the users. Now you'll notice this part is kind of, this already is functional down here. This is very functional and declarative. We're just telling the list to sort itself by the first name. But up here, we're actually responsible for all of the loops and the logic, right? So of course, this can be optimized to be functional, but in this case, I just went with an imperative approach. Down here, I'm sure a lot of you are familiar with SQL, which is quite a declarative language. So here we're doing the same thing, but it's a lot easier to read, first of all. And second of all, you can tell exactly what's going on, right? I'm getting a list of users. I'm going to get their matched addresses. I'm going to filter. So I only have these specific users, and then I'll sort by the first name. There's a lot less reading. And yeah, overall, this is just much easier to follow and requires less code, and it's a lot neater too. So again, and in this case, the underlying implementation is pretty complex for SQL, right? It's very optimized, but the programmer doesn't have to worry about that. They just have to worry about getting their desired result. So let's jump into a demo. So let's look at the UIKit first. I have two apps running here. This one, they're essentially the same app. This one is made with SwiftUI. And this one over here is made with UIKit. They're very simple. Again, you can enter, so you can enter some text. Oops. Well, let me enter text. Okay, so let's say we just enter text. If we enter a number in the username, it's an invalid username, so we show that message. And then the password is a secure field, so you can't see the contents of it. And let's just say we enter a username and password and then log in. It shows a loader, and then it's just going to return to the login state. So it's a very simple example, but the code, you'll see a major difference between SwiftUI and UIKit. So let's look at UIKit. Over here, it's again a very simple app. So what we'll be looking at is the controller and the view. So the controller is basically just doing the job of a view model here. It's providing some validation logic to check if a username is valid, and it just checks this simple regex. And then it also has a method to log in. So this part isn't important. This is largely the same between the two demos. Where the demos differ greatly is in the view. So here, this is the entire view. And what you'll notice is we have to define each view very imperatively, right? So we create the label. We turn off auto resizing so that, well, that's a more complex topic, but we're just going to turn it off so that we can add constraints later. We set the text, we set the font, and we return the label. Now we have a label that we can use after we do all this work. We also have a spacer here. It's just an empty view. We have a username text field. Again, so we create the text field, we do some configuration. And in this case, it's a bit more complicated because we want to do something when the text changes, right? When this text changes, let's say we enter a number. Oh, let me come back over here. If we enter a number, we want that error to show, right? So we have to be observing this text. So how we do that in UIKit is by adding a target. So when the editing changes, when the text changes, it's going to call this method that I have defined here. And this method will get the username text field's text. It'll check if it's empty or if the username is valid from the controller. And then it will do an animation to show that label, the error, if needed. So you'll notice we have a label there that shows and it animates nicely. But this is more work than we'll see with SwiftUI. We also have a method down here to do some transitioning between the loading states. So here we have a transition, we have another transition, and we have to start and stop the spinner whenever we click the button. So here we're responsible for all of that animation. So again, there's a lot more boilerplate. And then the part that really is kind of hard to read and doesn't make much sense is where we actually lay out the views and constrain them and make them all work together. So that's what this bit of code here is doing. This sets up all of the constraints. So you'll see the username text field, the top anchor is going to be constrained to the text field container, and the bottom will be constrained to the container too, so on and so forth. So there's a lot of extra boilerplate code here that we have to set up just to constrain it and make it look nice. And then, yeah, of course, we have all of our other views defined here. And yeah, so this is what we're looking at with UIKit. Again, it's not terrible. It's overall pretty clean, but it's just not very efficient. When I come and I look at this file, I have to examine the file to understand what's going on. I have to search for constraints to understand how something is being positioned. And it's just not efficient. There are better ways of doing this. If you've done anything with HTML and CSS, you know there's a better way. So what if there was a solution like that? That's what we're going to talk about now. So that's the UIKit demo.
Your audio just cut out. We can't.
We can't hear you, Austin Michael.
We can't hear you. I'm gonna Slack him.
Yeah.
I just sent him a Slack too to just be sure.
So this is the demo.
Can you like
and you go from one thing to the next thing, and as you can see, it says demo. Oh, and you can change the name. Let's see if I can. I'll call him.
Yeah, it might be worthwhile trying to mute him and then unmute him as well, like in Zoom. I don't know if that will help.
Seems he cannot hear us either.
Oh, I think we got his attention. We can't hear you.
He can't hear us.
He's working on it, guys. I think he's working on it.
Maybe saw.
We can't hear you, Austin Michael.
Can you hear us? That's the next question.
So guys, just wait for a word from our sponsors.
Yeah, sorry. I can hear you guys. Can you hear me now?
Welcome back.
I'm so sorry. I don't know when did you guys lose me?
About 5 minutes ago. About 5 minutes ago.
If you
Okay.
Go back to your slides.
Go back.
Just the problem. Yep.
I think here.
Okay, so sorry about that.
Okay.
Yeah, so the problem, creating user interfaces takes too much time. It's messy, hard to read and maintain, and requires too much boilerplate. All things we just saw with UIKit. The solution is SwiftUI, a lightweight wrapper around UIKit. It's designed to be declarative, easy to read, works across all Apple platforms, including Mac OS, and it eliminates the boilerplate code that we just saw. So let's go back to the SwiftUI demo now. Okay, so looking at the view model, we'll see this part is largely the same. It's pretty much the same as the controller from the UIKit demo. But up here, we have a published variable, and it's a username. We have a password and a Boolean value denoting if we're logging in or not at the current moment. And what published means, and this is really cool, essentially it means it allows for two-way data binding. So the view can bind directly to this view model. And there's no extra like steps to get the two-way data binding to work. And I will demo this side by side in a couple of minutes, but we do have two-way data binding built in right into Swift. So then looking at the view, I mentioned before, we have this preview and it automatically updates. Okay, so that's a big step over UIKit, because with UIKit, you have to rerun the app every time you make a change. But here we have a live preview that updates automatically. We have a state object view model, and this also just allows for binding to the view model. So we define our view model, and then essentially the view just becomes a function of the state. So when the state changes, the body will automatically update. That's how SwiftUI works. If there's a change detected in the state, it will re-render the body. It will recall this method and do any re-rendering that it needs to do. So you can see it's very readable. We have some space up here. We have our text. We have some more space down here that's takes up more space than this group up here. We have a text field with username, and it's a custom text field style. And then this is one of the really cool things of SwiftUI. Even though the body is a function of the state, we can still include all our control flow right in the body. So here we check if the username is valid. And if it isn't, we are going to show the invalid username text. And that's all we have to do. We don't have to worry about any other animations or showing or hiding a view. It happens automatically with our control flow. And then we have a secure text field here, which is for the password. We have some more spacers, and then an if else here. So if we're logging in, we'll show that progress view, the spinner. Otherwise, if we're not logging in, we'll show the button. And then at the end, we just have a little extra space down here. And then I showed how animations work in UIKit. So you have to do stuff like this, where you trigger a transition. But with SwiftUI, you just say, I want an animation. It's going to ease in over 0.15 seconds. And I want this animation to trigger whenever the username changes. And automatically, this animation, if the username changes, it will animate any changes that happen in the view. So this is pretty cool. And another really cool thing that I mentioned was that it works automatically across iPad and Mac. So this is a native Mac running, a native Mac app running, and this is an iPad Pro running. So that's really cool. And there are also some very easy tools for us to use, size classes. Any iOS engineers, you'll be familiar with that. But for example, here on an iPad, we don't want the username fields and the button to stretch across the entire width of the screen. So we can check if the width is compact. If it's compact, it means we're on a smaller device, so we don't want any maximum width. But if it's not compact, we set it to a maximum width of 384 pixels, which is what we're seeing here. So also dealing with size classes and different size screens becomes very, very easy with SwiftUI. Another thing that comes automatically with SwiftUI, which is really cool, is dark mode. So I can go on and turn on dark appearance, and I'll come back to the app, and it automatically updates. It just works like this out of the box, which is awesome. And if you've worked with UIKit, if I turn on dark appearance over here, you'll notice some things update, but some things don't. So that requires more boilerplate code to go and make sure that your app is adaptive to dark mode. So let me turn this back to light mode so that we can see the entire app. So that's kind of a demo of SwiftUI. So let's look at some things side by side really quick. UIKit with the imperative approach. Here, we're just creating a simple button, positioning it on the screen, and giving it an action. So we create the button, we set the title for the normal state. We set the font, we set the background color to blue, so it'll look like this. And we also give it a border radius or corner radius. And then again, we have to add a target so that when there's an action on the button, we call this onPress method down here, and that will print a message. And again, we have to turn off some auto resizing things and then position the view on the center X anchor and center Y anchor. That's a lot of work for just saying, I need a button that when you press me, I just print a message. And that's exactly what we can do down here with SwiftUI, much easier. So we just have a surrounding Z stack and a button that when you press, it prints a message. And we give it the button style of bordered prominent, which is this button style here, blue with a rounded corners. So you can see the declarative approach is much, much simpler. We have far less code and it's much more readable. So yeah, again, readability. In this case, we have to examine the code to understand what the component is, what it's doing, where it's positioned. Whereas here, we know exactly where it's positioned. We know what it's doing and we know what it looks like. It's super, super simple. When it comes to boilerplate code, again, SwiftUI takes the award here because UIKit, just creating and styling the button is 5 lines, right? And then to print a message, we have to add a target and we have to define a function down here, which is another 4 lines. Positioning the button, another 6 lines. Whereas SwiftUI, again, we just say button, I want it to print a message and I want it to look like this. And this is a bit of a different example. This is data binding. So here with UIKit, if we want two-way data binding, and what two-way data binding means is a text field will automatically update its associated variable, right? So the username text field will update the username property, and the username property will update the username text field. So it's bound in both directions. They're bound to each other. So in this case, we have to create a text property. We add a property observer. If the text has actually changed, we assign it to the text field. Then when we create our text field, we add another selector whenever the editing changes, and we assign the text field's text to the text property. And with SwiftUI, it's just 2 lines. So much, much, much simpler. We create a state variable called text, and we pass it to the text field, and that's it. Now, when the text updates, it updates the text field. When the text field updates, it updates the text. So we've achieved two-way data binding with just 2 lines of code. So yeah, we've looked at a lot of great things about SwiftUI, but what are some cons? Obviously, nothing is perfect. So SwiftUI is still very early. Again, it was only released in 2019. So some adoption hasn't really been there yet, and the community is still growing a lot. New iOS versions, again, because it's still very early, typically can introduce breaking changes. For example, when we moved from iOS 13 to iOS 14, there were a lot of breaking changes, and those 2 platforms can kind of give developers a run for their money. Not as many features have been implemented as UIKit, of course, because SwiftUI is built on top of UIKit. So of course, UIKit currently has more features just because, again, SwiftUI is very new. So we sometimes require workarounds because not all features are available. And it only supports iOS 13 and up. This is a problem only depending on the company. Again, I mean, 85 to 90% of all iOS devices worldwide are running iOS 13 and up. So that's a situational issue. And then SwiftUI Pros, again, let's just do a quick recap. You have live previews for faster prototyping. You have less boilerplate because it's declarative. You can just tell SwiftUI what you want. It's more readable and compact. It has built-in data binding, and it works across the entire iOS ecosystem. So SwiftUI overall is a great step for the iOS community. It's a step in the right direction. It modernizes iOS development a whole lot. And yeah, I mean, that's SwiftUI versus UIKit. Here are some useful links if you want to do some extra reading. And other than that, do we have any questions?